So this video has got a number of infrared spectra where we're going to go through some of the details that go along with this. This one here is ethane, and all that we've got here are C's, and we've got some CH's. So over here, if we were to click over in this region, we have here we go. We've got these peaks over here, and that's going to go with an anti-symmetric stretch, and this one is a different kind of a stretch, also not quite symmetric, and so there's a bunch of different kinds of stretching motions that can go along. Here's the symmetric stretch, where they're all going out and in together. So these are all the different kinds of CH stretching modes we can have. And they're all about 3,000, mostly on this side of the peak. Now, over here, we've got a bunch of different wags going on here. So there we've got that scissoring mode and some rocking modes. So these are some of the things that we saw in the other video. Let's try a different spectrum. So here we've got ethene, it's also called ethylene, and this spectrum looks pretty different. And we've got a number of different things. So first of all, some of the CH business is going on out here quite a bit further to the left. So here we have these CH stretches attached to a double bond. Different kind of CH stretch attached to double bond. That's the symmetric stretch attached to the double bond. And here we've got another version of stretch attached to the double bond. And mostly it's on this side of the 3,000. So the 3,000 is kind of a handy marker to help you to notice whether it's on a double bond or on a single bond. Over here, we've got some other peaks of interest. In here, we have that CC stretch. So this is in the 2,000 to 1,500 is where we've got a lot of this CC business going on. And when we get down over here, we've got less of the stretching, more of the bending modes going here. And there we've got twisting mode going there. And here we've got a out of plane wagging mode. Let's move on. And here we've got a spectrum. And this one is ethine, also known as acetylene. And that's the business from the torches. And there's nothing going on right here. Here's the big stretch. Okay, here we've got our big CH stretching peaks. We've got a symmetric stretch, and we also have an asymmetric stretch. This molecule doesn't have very much else to happen here, so that's all you're getting out here. And in this case, we're not really seeing the C double bond C, and that's because this molecule is completely symmetric, and that causes some peaks to not show up where you might think they would be. And then down here we've got some, that's the stretching again. Here we've got some out of plane sort of waggy things going on. So it's a pretty simple molecule, it's only 4 atoms, there's less going on in the spectrum. So let's try this one. This is actually a spectrum we were looking at before on the other video. And now we can animate it, which is pretty cool. So we have the 2 kinds of CH stretches, the ones that are on the singly bonded carbon, and the ones over here that's on that triply bonded carbon. And those are really clearly distinguishable. Over here, we have our CC stretch, very obvious in this molecule. And then we got a bunch of bendings and stuff down here. This video isn't going to highlight it for this particular website. For these others, for more bends and twists and wags. Okay, so that was the propyne. And here we've got 2-butyne. And I want you to notice there really aren't those triple bonds C's with an H on there because there aren't any H's directly on the triple bond. The triple bond is internal. So we see this, okay, which are those various, that's actually the WAG, going on with the CC, the CH on a carbon, that's CH, that sp3. And here we've got that C triple bond stretch. It's not as obvious in this spectrum as it was in the other spectrum. And now I've got a couple more here. This molecule has a carbonyl group in it. This is a ketone. It's got the C double bond O. And the most prominent feature of this thing here is this. That C double bond O stretch at about 1700 is very, very obvious. And when you see it, you know you have a carbonyl group in your molecule. And then I have this molecule here, which is we have an alcohol group, OH, and there's a very, very prominent feature that goes along with that. And it's not this. These are all these CH stretches, the various CH stretching modes over here. And this thing is this CH stretching mode there. And it's a big broad peak. I'm not sure why it's disappearing in the animation, but the reason it's so broad is because in a solvent, this can hydrogen bond, which means that not every single OH is in exactly the same environment. They could be closer to the next molecule in the liquid, they could be further from the next molecule, and that'll spread out the peak. If you were to do this in the gas phase, where the molecules were isolated, you would see a regular strong peak, but not this big broad peak. It's because it's hydrogen bonded that you get the strong broad peak. But if you see something like this in your infrared spectrum, you say, oh, my molecule's got an OH in there somewhere. And that can be really, really helpful, particularly in conjunction with the NMR to try to get the groups down. So that's the end of this video, and I hope that's working for you. And take a peek and try some problems.